going to be going ahead and going through 4 specific heat problems. I noticed that some people might be struggling a little bit, so I kind of wanted to go ahead and go through like 4 examples of like the 4 different types of problems that you guys can actually get when we're going ahead and we're solving for Q is equal to MC delta T. Okay, so first and foremost, as a recap, right, we have the equation that we're working with, right, which is our Q is equal to MC delta T, right? Delta T is going to be our change in temperature, and that is going to be in Kelvin or Celsius, right? C is specific heat, okay? Please make note that it says specific heat, right? And specific heat is different from heat slash energy, which you see here, right? So this one right here is heat slash energy, right? And that's one that you'll see here. Specific heat, you guys will see more commonly, it's in joules over grams degrees Celsius, or, right, joules over kilogram Kelvin, right? So that's the unit on there. For Q, it's either joules with a J or calories. And you guys have already seen calories, and calories is with a C. M is going to be our mass, right? And mass is always expressed in grams. So those are your things that you guys will see on there. Kelvin or Celsius. So that's kind of the recap of our equation. All right, so now we're going to go ahead and we're going to get into solving some problems, and we're going to talk about specific steps that you need and all of that to go ahead and to solve those problems. Okay, so we're going to start with our first step, and we're going to start by reading our problem, and then we're going to figure out what they want us to go ahead and do with this. Okay, so it says, what is the specific heat of a 135 gram piece of aluminum if the temperature is increased by 8.7 degrees Celsius when 2,045 joules of heat is absorbed? Okay, so when you read this, right, don't get overwhelmed by the numbers or anything, right? We're going to go ahead and we're going to break this down. So first thing is that we're going to go ahead and we're going to figure out what they're asking us for and list the things that they give us, right? So if you go ahead and if you go through the problem, right, you see that we have that there, we have this number here, and we have this number here, right? So those are the numbers that they give us, right? And then our question is, what is the specific heat, right? So going ahead and looking at this, right? So our step 1, right, we are solving for specific heat. And specific heat is C, right? So that's going to be our step 1, right? Our step 2 is list knowns, right? So we're going to list what we know, right? So we have our 135 grams of aluminum, right? And that is a mass. We have 2,045 joules, and that is Q. And I know that because, first of all, it says heat, right? And Q is heat slash energy, and it's also expressed in joules, right? And then my temperature increases by 8.1 degrees Celsius. Right, so 8.1 degrees Celsius is a delta T. Right, so now I'm going to go ahead, I'm going to solve and check for units. So I'm going to change my pen over here. We're going to solve and check units. All right, so that's going to be our next thing on here. So first of all, I like to go ahead and I like to write my equation, right, which is a Q equals MC delta T. I'm going to go ahead and to plug in everything from step 2 is going to go up here, right? So I'm going to have my Q, which is 2045 joules, right, is going to be equal to M, and my M is what I'm getting from there, which is 135 grams. And then I'm going to multiply that by my C, which is what I am looking for. So I'm going to put that in green because that is what I'm looking for, which is my C. And then I have my delta T. Oopsies. And then I have my delta T, which is 8.1. So I am going to go ahead and I'm going to put that there. 1 degree Celsius. So you guys will see that I didn't drop any of the stuff. Okay, so now I'm going to go ahead and I'm going to type the stuff in. So now I'm going to do a little bit of math. So on this side, right, on my right side, what I'm going to do is that I'm going to go ahead and I'm going to multiply. Right, so I'm going to multiply my right side. So when I go ahead and when I multiply this, I go 135 times 8.1. And if I do that, I get, let me switch my pen back. So when I go ahead and when I do that, I go ahead and I get 1093.5. I'm also not going to go ahead and I'm not going to drop any of my units. I'm going to keep those units there. And then I'm going to put my C. So I'm going to go ahead and I'm going to bring my C down that I'm multiplying by. Right? And that is all equal to whatever we have in joules. So 2045 joules. Right? So now I have to go ahead and I have to isolate this C right here. Right? So I'm going to go ahead, I'm going to isolate that. So in order to go ahead and to isolate that, I am going, to divide. Right? So I'm going to go ahead and I'm going to divide by this on both sides. Grams degrees C. So I'm going to go ahead and I'm going to divide by this. So I go 2045 divided by 1093.5. And what I should get is I should get 1.87 joules over grams degrees Celsius. Right? And that is going to be equal to C. Right? So just as a quick recap, how I got that number is that I went ahead and I divided right here. So I went ahead and I divided, right, to get my C, that's right here. I want to isolate this. Right, so same thing that you guys do in math, right? You have to go ahead and you guys have to divide to isolate. Okay, so the next thing that we have to do is that we have to go ahead and we have to double check units, right? So we're going to make sure that our units are okay. And in order to do that, we are going to go ahead and we're going to check units. So I go ahead and I go up here and I see, am I in joules, degrees, joules, grams, and degrees C? So I am yes, right? I have the correct units for C. Right, so I have the correct units, which means that my answer is pretty much on the right track, unless I went ahead and I messed up somewhere and I did not convert, or I forgot to do something, or if I did. Hey guys, so we're going to come back into our second problem, where it says specific heat of silver is 0.24 joules over grams degrees Celsius. If 15.4 grams of silver absorbs 320 joules of heat, how much will the temperature increase of the silver increase by? So we have a few things to go ahead and to kind of set up for us. So we have our step 1 and our step 2. Right, so our step 1, right, we have to figure out what is our question that they're going to go ahead and they are asking us. Right, so going ahead and looking at our question, we will see that they ask us how much will the temperature increase by. Right, so in this case, right, we're looking for temperature. right? So we're looking for temperature, which is delta T. Right, the next thing that we're doing is that we're going to go ahead and we're going to list everything that we know. So when we're listing everything we know, like as I was reading, we were looking at the numbers, right? So we had this number and we had that number. So now we have to figure out what they all mean, right? So I had 0.24 joules over grams degrees Celsius, right? And if I look at my units, like I can look up here, right? I look and go ahead and find my unit, and then I see that joules over grams degrees Celsius, whoopsies, is your C, right? So this is going to be represented by the letter C. Then I have 15.4 grams, right? And that's going to be represented by the letter M because that is a mass. And then I have 332 joules of heat. So 332 joules, and then since that is just heat itself, it is going to be Q, right? And again, I get it from looking at my Q equals MC delta T, right? So now I'm going to go ahead and I'm going to plug these things in. So we're going to go to our step 3 and 4. We got to solve / check for units. So now I have Q is equal to MC delta T, right? I have my Q, which is in this case 332, right, joules, and it's equal to my M, which is in this case 15.4 grams. Then I have my C, which is 0.24 joules over, I'm going to write it this way, joules over grams degrees Celsius, and then I have my T, which is what I'm looking for. Right, again, I'm going to go ahead and I'm going to multiply. I'm going to multiply the 15.4 times 0.24. So I'm going to go ahead and I'm going to go 15.4 times 0.24, and I get 3.696, right, grams joules over grams degrees C, right, is equal to 332 joules, right? I have grams on the top and grams on the bottom, so those things cancel, right? So in reality, what I actually have is I have 3.696 joules over degrees Celsius, right, is equal to 332 joules, right? Now I'm going to go ahead and I'm going to divide, right? So I'm going to divide, this number right over here to get my delta T. I dropped my delta T. So I'm going to get my delta T by dividing so that I isolate my delta T. And when I go ahead and when I divide, what I'm going to be dividing by is 3.696, right? And then I'm going to have, because when you divide it, you're going to have degrees Celsius over joules. My joules are going to cancel, right? And then when I divide that, I will get 3.696. I should get 89.82 degrees Celsius, right? So that is what I should get on there, right? And again, right, I have to go ahead and I double check my units. If it is in Celsius or if it is in Kelvin, I am good, right? So that one is that problem right there. So always make sure you guys are checking your units, and always make sure that you guys are going ahead and keeping those variables so that you are able to go ahead and able to double check your answer. Okay, so we are back with our third problem, and we have the specific heat of water is 4.186 joules per gram with our Celsius on there, what is the mass of water that can be heated from 25 to 50 degrees Celsius by the addition of 2,825 kilojoules? So what we're going to do is that we're going to go ahead and we're going to start with our step 1, which is our question. So we're going to figure out what they're asking us, and then we have our step 2, which is to go ahead and to figure out our knowns, right? Knowns, and step 1 is our question. So we have all of these numbers that they go ahead and they give us. We have our 25 degrees Celsius to 50 degrees Celsius, and we have all of these numbers, and they're asking us what is the mass. Right, so we have to remember for step 1, they're going to go ahead and this is going to be our question or what they're asking us, right? So on here, right, they're asking us what is the mass of water, right? So we have our mass. So now we are going to go ahead and we're looking for mass. So mass is going to be our question mark, right? And that's the thing that we're looking for. So now we're going to list off all of the things that we know, right? So I have my Q, which is my heat. Let me rewrite that. So we have our heat, which is 2,825 kilojoules, right? And that is going to be our Q. We have our specific heat. Again, remember the only difference between heat and specific heat is one says specific, right? And the units are different, right? So we have 4.186 joules over grams degree Kelvin, and that is going to be our C, right? And then we have our temperature, and they give us 2 temperatures. They give us our temperature as 25 to 50. Right, so they give us 25 degrees Celsius to 50 degrees Celsius, right? So now what we have to do is that we have to actually find a delta T. So we have to go ahead and we have to find the difference between this 25 and 50. So what you do is delta T is equal to T final minus T initial, right? So the first, what we started with was 25 degrees, right? So since we started with 25 degrees, I'm going to give myself a little bit of room here. Since we went ahead and since we started with 25 degrees, right, what we're going to do is we are going to go ahead and we're going to put that right here so that we started with 25 degrees Celsius, right? And our final, so what we ended up with was 50 degrees Celsius, right? So, and then our delta T, if we went ahead and subtracted that, right, that is going to be equal to 25 degrees Celsius, right? So in this case, right, delta T is, so in this case, your delta T is going to be equal to 25 degrees Celsius. I'm not sure what I did there. So delta T is 25 degrees Celsius, right? So I have my Q, I have my C, and I have my delta T, right? So now I'm going to go ahead and now I'm going to go into my step 3, which is I'm going to go ahead and to solve this. So I have my step 3. We got to solve and we got to check units. Right, so we're going to start off with our equation. Q is equal to MC delta T, right? I am going to go ahead and write down what I have. So I have 2,825 kilojoules is equal to M, and then my C is 4.186 joules over grams degrees Celsius. And then I have my delta T, which I solved for, which is 25 degrees Celsius. right? So I'm going to go ahead and I'm going to do a unit check, right, at to see if everything lines up. So I have Celsius here and Celsius here, so that checks off. I have grams, and I'm going to have grams here because that's how mass is measured, which is good, right? I have joules here, and I have kilojoules here. So what you will see is that my joules and my kilojoules, right, those things do not match, right? And because joules and kilojoules do not match, what you have to do is that you have to go ahead and you have to convert it. So now I'm going to go ahead and I'm going to convert to joules. Convert to joules, right? So we're going to convert to joules. So the way that we do this is that we have to kind of go back into our conversion deal, right? And we have our whole King Henry died drinking chocolate milk, right? And that's how we do our conversions. Joules is here, right? Kilojoules is here, right? So since I'm going from kilojoules to joules, I have to move my decimal point 3 times, right, the same way, right? So since I have a decimal point here, I'm going to have to move the decimal point 3 times over. So when I go ahead and when I move my decimal point, my new number is going to be the following. So I have 2825, and then now I have 3 extra zeros, right? Joules is equal to, right, and then my mass, my M, and then my 4.8 joules over grams degrees Celsius times my 25 degrees Celsius, right? So now that my units and all match, right, I am going to go ahead and I'm going to multiply, right? So I'm going to multiply. And I'll multiply those out. So 4.18 times 25. So 4.186 times 25. I go ahead and I multiply that, and I get 104.65, right? Joules over grams degrees Celsius. And I have a degree Celsius here, right? And then I have my M is equal to 282500 joules. Oopsies, dropped to 0. Right. So now I go ahead and I look at those. I check my units again, and I see that Celsius and Celsius cancel, which is good. And then I am going to go ahead and I'm going to solve for the rest of the equation. So now I have to go ahead. So now I have to go ahead and I have to divide. So in order to go ahead and to do so, right, I'm going to go ahead and divide this last deal at the bottom so that I can go ahead and that I can isolate this. So in isolating this, this is what I should get. So I'm going to divide this by 465 joules over grams. I have 104.65 joules over grams. Right, so when I go ahead and I'm doing this, I'm dividing. Divide to isolate M. Right, so I go ahead and I divide to go ahead and to isolate my M. And when I go ahead and when I divide, this is what I should get. So go ahead and divide that deal. So 2825,123 divided by 104.65. And then this is what I should get. I should get 26944.74, right? My joules are going to go ahead and my joules are going to cancel, and I am left with grams is equal to my mass, right? And then I check my units, and my units should be in mass. Hi, so we're going to go ahead and we're going to finish off our last problem. So we have the specific heat of water is 4.186 joules grams degrees Celsius. How much heat must be absorbed by 375 grams of water to raise the temperature by 25 degrees Celsius? So we are going to go ahead and we're going to do the same thing. We're going to do our step 1, which is our question. So step 1, what are we solving for? And then we are going to go ahead and we have to do our step 2, which is our knowns. Right, so our knowns are each of these that we have on here. Right, so we have all of our numbers are our knowns, so I kind of go ahead and kind of do that. And then they ask us how much heat. Right, so how much heat is what we are going to go ahead and what we're solving for. So this is how much heat, and that is going to be our Q variable because our Q goes ahead and it stands for heat. All right, so now we go with our known. So what are the things that we know based off of our problem? So we have our 4.186 joules over grams degrees Celsius, right? And that is going to be my specific heat. And the specific heat is represented by the letter C. Then I have my 375 grams, right? That is going to be a mass, and that is going to be represented by the letter M. And then I have my temperature, right, which is in this case 25 degrees Celsius, and that is going to be represented by our delta T, right? So now our step 3 and 4. So now we have step. We're going to solve and check variables. Check units, my bad, not variables, units. So we're going to solve and check for our units. So we're going to go ahead and look at our Q equals MC delta T. Whoops. So Q is equal to MC delta T, right? Then we are going to go ahead and we're going to solve for Q. So we're going to leave Q alone. Right, we have our mass, which is what we have on here, which is 375 grams. Then we have our C, which is 4.186 joules over grams degrees Celsius. And then we have our temperature, which in this case is going to be 25 degrees Celsius. Right. Then I'm going to go ahead and I'm going to make sure that all of my units match, right? Celsius and Celsius, grams and grams. So that all matches, which leaves me with joules, right? And that is exactly what I want. So I am going to go ahead and I'm going to just multiply these things out, and then I should have my answer. So what I'm going to do is that I'm going to multiply. And then I should have what Q is equal to. So if I go ahead and if I multiply this real quickly, 375 times 4.186 times 25, I get 39,000. So I will have 39243.75, right? Joules is equal to Q, right? And then again, for this answer, it needs to be in joules, right? So Q, units for Q are either joules or calories. So units should be joules or calories, right? And I have joules and it should be joules. So then that means that my problem is good and I am good to go, right? So the main thing about all of these problems is that you guys are, number one, figuring out what you're solving for, and then going ahead and going through your knowns. Like I was doing here, you can go through kind of both of these at the same time, as long as you figure out both things so that you know how to set up your equation. Always be super careful with units, right? Look through your units, make sure that all your units match. If your units do not match, then more than likely you are going to have to do some sort of conversion so that you get your units to match. And then last but not least, if you ever get two temperatures, right, make sure that you're going through delta T, so T final minus T initial, right? So always be careful with temperatures, right? Watch your units, right? And then just list out what you have. And if you're able to list out what you have, then you should be able to go ahead and to solve all these problems successfully.